So I'll begin with a word of prayer here once I get up front. Dearly Father, we thank you for this day. Thank you for this class. And just ask you to bless our work today. Help us to glorify you in what we do, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
All right. Whoa.
No.
Is that better?
Well, here, you feel it.
Oh, that's hot.
Yeah.
Wouldn't recommend using that laser pointer. Unless you have...
So, that's weird. Oh, I smell that. Huh. All right. I gotta get some. Man, what is that? Maybe those batteries are bad. Aw, man. Oh well. All right. Let's do these problems.
Oh.
So, example 1. We have y equals the cube root of 3x minus 2. Now, if I want to find the formula for the inverse, what do I do, Michael?
You need to multiply to the power of 3 on both sides.
Okay, so and why are we going to do that? We're going to do that to try to solve for x, right? That's our goal, is to solve for x. So this gives us 3x
equals
y cubed plus 2
divided by 3.
All right, so x is equal to 1/3 of y cubed plus 2. That is the quote-unquote stuff in y. So what's the formula for f inverse of y?
Oh, so f the inverse of y is 1/3 y cubed plus 2.
Very good.
Yes! Nay!
Very good, Michael. All right, so how about the next one, guys? How do we graph? I don't know if I did an example like this yet, right? How are we going to do this? What's the theorem I told you guys last time? That if the point
if AB, then BA.
If AB is on the graph, then BA is on the graph of f inverse, right?
Inverse.
So to find the graph of the inverse, what you do is take the points that you already have and flip the y and x. So here, 0, 2 means that I've got the point 2, 0 on the graph of the inverse. This one, 4, 2, so that should be it right under that. And then 4, 2 be like here-ish. And then finally, 4, 6 flips to 6, 4, so roughly here-ish. So here's the graph of the inverse. And, if I had graph paper, it would look better and stuff. Obviously, it's not coming out very well. It should be the exact same shape. It should be like reflected. It should be really reflected across the line y equals x, okay? So it should have kind of looked more like something like, you should have the same kind of bending, if you will. Should look more like that, let's say. So I don't know. I'm freehanding coordinates here, so it's what I can do.
But what, the lines are straight?
I want the lines so the original lines are straight, and I want the reflected lines to also be straight. Should be like the same pattern, but reflected. Here, let me do another one of these, okay, guys? So like example 3.
Oh, Roger that.
If I had let's see here, like that. So let's say this point right here is minus 3 minus 1. And let's say it gets over here to the point 3 comma 10, perhaps. All right? And it's going through the origin. If this is y equals f of x is given, what's the graph of f inverse look like? So remember, it has to be the reflection of the graph across the line y equals x, wherever that is. I'm not sure that's actually it, but roughly speaking. And what we can for sure hang our hat on, so to speak, is just taking these points and flipping them over. That will be on the graph of the inverse. So if minus 3 minus 1 is on the graph of f, then minus 1 minus 3 is on the graph of f inverse. And on the other hand, the point 0, 0, what happens if you flip 0, 0? Nothing, right? So that point will be both on the graph of f and on the graph of the inverse. And then this point up here, 3, and obviously my dotted line's not very good. Really, like y equals x is something more like
10.
I don't know. Well, where's 10, 3? So if that's 3 over, 10 would be like 3 of those, and 3 up. So 10, 3 is something like here-ish. And so what's going on here is you got something like that. All right? There's y equals f inverse of x. And again, once we have, I usually, when I have this kind of problem on the test, I give it with a graph paper so that you can be more systematic in your, graphing of things like this. But if I did this right, it should be symmetric around the line y equals x. That's how the graph works. All right? Any questions? Yes, Michael.
Can you give me an example of problem number 78 on my mission, since we haven't gone over it and we ran out of time? Can you give me an example that's like it?
I can try. My computer will work. Well, come on. All right, Microsoft Teams, you're dead to me. I'm ending your task. I tell you, Microsoft Teams, it does bad things. Why do I have Microsoft Edge open? I don't want that either. Something is making my computer freeze, so a virus. My son did have a fever yesterday.
Unrelated.
I think it was viral. Let's see here. We're on mission what?
Mission 3.
Mission 3. And where did you find mission 3, Michael?
At the all the way down to the end.
All the way down to the end, right? So if you guys are looking for mission 3, it's in like a week or two from now.
13,
Yeah.
12.
But it's there, waiting for you.
After Thanksgiving break.
Week after Thanksgiving break? Okay.
I plan to study hard.
Okay.
Yes.
So example, let me put this away here. Example 4, which will be like the one Michael's asking about.
All right.
This is like problem 78. Problem 78, you're given a particular formula and you're asked to find the formula for f inverse of y. So the formula is something along the lines of this. 10 plus 7 over x minus 3. It's not exactly that, but it's kind of like that, okay? So how do we find the formula for f inverse of y? What we do,
So we need to Y equals.
We set y equals to the formula. And then our goal is to solve for x.
Solve for x.
So,
Multiply.
well, first thing I'm going to do, Michael, is I'm going to subtract 10 to the other side.
Minus 10. Negative 10 y.
So y minus 10 is 7 over x minus 3. And then what I'm going to do is I'm going to multiply, I'm going to basically swap places. So if this is the case,
X minus 3.
we can trade that for x minus 3 is equal to 7 over y minus 10.
So just switch position.
Yep.
Minus 3.
Now to solve for x, what do? Add 3 to both sides.
X equals.
So Michael, you can't be talking during class, man.
Oh, sorry.
So 7 over y minus 10, like that.
X equals.
So now we have solved for x, and that is the formula for f inverse of y.
Is it f negative x?
Well, this is in terms of y. If you want f inverse of x, you just change the letter. So if that's f inverse of y, then f inverse of x, same formula, just different letter, 3 plus 7 over x minus 10. Yeah.
Thank you.
Okay. All right, so let's look at another example here, guys. So example 5, my bad. Example 5, suppose we're given f of x is equal to 3x minus 1 over x plus 4. So I want us to do a few things. I want us to figure out what is what's the formula for f inverse of y, but I also would like for us to figure out what is the domain and range for the function, and also what is the domain and range for the inverse function. All right? So can you guys tell me what is the domain for the function that I just wrote down? Can you guys tell me that? What's the domain here?
Upper back.
So what we got is minus infinity to minus 4, unioned with minus 4 to infinity. In other words, the domain is all x except for except for negative 4, because that's where we've got division by 0, right? And so that is going to be equal to the range of the inverse function. All right? I don't even know the formula for the inverse function yet, but guess what? That's its range. Okay? Now what's the range of the function? I don't know. I'd have to graph it, right? But we can figure it out. Let's do it. Well, I'm going to do it in a kind of sneaky way. So you guys find the formula for f inverse. Find the formula for f inverse here. What's our starting move? We put y equal to the formula, right? So we're up against y equals to 3x minus 1 over x plus 4. We need to solve for x. How do we do that? So this is going to give us x plus 4 times y is equal to 3x minus 1, multiplying the denominator to the other side. Now I should distribute, right? This is going to give me xy plus 4y is equal to 3x minus 1. And then, man, I wonder why this thing got so hot. Weird. I wonder if it's the laser or if it was the batteries. That's what I'm wondering. Let's find out. Huh. Oh, that way. Well, here goes nothing. Do 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 do. Okay. I'm kind of worried about putting this in my bag now, though. All right. So, no fire yet. It's a good thing. So, let's see here. We got x's here. We got x's there. Let's put all our x's on one side. So this gives us xy
Oh, so
minus 3x is equal to minus 4y minus 1. Now we can factor out.
So I don't interchange the fraction.
Well, I don't know, but we factor x out here. We have x times y minus 3 is equal to minus 4y minus 1, which gives me x is equal to minus 4y minus 1 divided by y minus 3, which I kind of like to write that instead as 1 plus 4y divided by 3 minus y. I mean, that's whatever. Either formula is really fine. So there you go. That's the formula for the inverse function. Let's write it down. Still cold. Good. Just checking. So we got f inverse of y is equal to 1 plus 4y divided by 3 minus y. There's your formula for the inverse function here. Yes, Michael?
So how did you add both 1 and 4 at the same time?
Oh, what did I do here?
Yes.
Well, I multiplied the top and the bottom by minus 1, if you like. You could think of it that way. Minus 1, I can do that, right?
Why do you multiply it by minus 4?
Because I just don't like having so many minuses. Just to have mostly positive terms. Just simplification.
So,
No reason.
when should I multiply by a negative?
It's a question of style. It's like, why did you wear the shirt you wore today? As opposed to a different shirt.
It's much nicer to use that.
No answer?
With all positives than that many negatives.
It's clean. That's a legitimate reason.
Amen.
It works for some people.
So
Yes.
The range. So the range.
Ah, yes.
So the range is y. What letter goes before the e?
Oh, element of? Yeah, you guys tell me. First, what is the domain? Let's talk about the domain of f inverse. Can you tell me what the domain of the inverse function is? Y such that what?
Y.
I'll use this so-called roster notation. Y not equal to what? What is the one thing we can't have in the y formula that I just boxed? I heard a 3. Right. So y such that y is not equal to 3. Now let me write that in interval notation up here. So we've got the domain of f inverse is equal to minus infinity to 3 unioned with 3 to infinity. And so remember what we talked about last time? The domain of the function is the range of the inverse function and vice versa. The range of the function is the domain of the inverse function. Oh, so the domain of the inverse function, that's easy to figure out. It's just where the formula for the inverse function breaks down. Where does the formula break down for us here? 3. And that has to also be exactly the one value which is not covered in the range. So this is a sneaky way, in some sense, to calculate the range. How did we calculate the range of a function before? What did we do? I think I heard somebody say graph. That's right, we graphed it, right? I didn't have to graph the function, and yet I can figure out what the range is just from looking at the formula. Now, if you look at the formula, you can understand why that's the range. If you do some long division, perhaps, right? It's not an accident that 3 is the horizontal asymptote of this function, right? The ratio of the leading coefficients is 3 over 1. Y equals to 3 is the horizontal asymptote. That's the one thing that the range doesn't go through as it happens. That's why we were missing 3. Any questions? Yeah, Michael?
So, after class, can you help me with problem number 7?
Well, after class, I have to go teach the other class, but I can answer your question now, maybe.
Oh, YR.
Which problem? What problem?
No. It's okay. I've caught up.
Okay. Good. So, listen, guys. With the time that remains, I think it would be productive for us to go back and look at the solution to test 2, right? Would you guys like to do that?
Sure.
Let's talk about, if I can, this computer is giving me fits today.
But I didn't bring the test with me, unfortunately.
Well, I'm sorry about that, Michael. Let's see here.
You got them?
Oh.
You can pull them up on your phone.
Well, I'll have the test out here in just a second.
I'll fix them at my free time.
All right. I think I got too many tabs open or something. Trying to close some tabs. All right, here we go. So by the way, guys, that's, well, there's one other kind of example I should do today, I guess. What's the one other kind of example that I haven't done yet for you guys? I guess we'll come back to it after we're done looking at this test. But so sorry I made the first one so like just, yeah. I meant to scramble the answers and I forgot, but so ABCD was what it was. So this, of course, has x plus 2 and x minus 2 both squared, which makes them both volcanoes. So it pretty much had to be that one. This one has a horizontal asymptote of 2. The only one of these with a horizontal asymptote of 2 is that one. So it has to be B. This one's a square root shifted up by -1 and shifted over by shifted over left 2. It's got to be this one. And also this is the only square root, so it has to be that one. This one, if we factor x out, we've got x equal to 0, x equal to 3 is vertical asymptote, so it has to be this one. But anyway, most of you got that one, okay. This one here, by the way, I still haven't had, and I have not had yet time to sit and meditate upon the average score for this class and the other class. There may yet be a curve on this test. I'm not done yet with the grading, so just a comment. I will let you know once I've actually had a chance to sit and think about it, okay? It hasn't happened yet. But here, basically just make a common denominator of x times x minus 1, and it simplifies like that. This one, we have to multiply through, and when we do, the x minus 2 reduces here, but the x plus 2 reduces there, and we get x plus 2 minus a parentheses x minus 2. Some of you missed this parenthesis and then got it wrong. But when I do that, that gives me 2 plus 2, which is 4, and the x's cancel. These are both pretty similar to homework problems that you guys had, right? This problem 3, we make a number line. The critical numbers are 0, 8, and minus 3. So you plug in, get your sign chart and look for less than 0. So I'm either here or there. I can't divide by 0. I can't divide by 8, so I got to exclude those. Excluded. Minus 3, fine, that gives me 0. Included. Hooray. Problem 4 was actually the same problem. Oh, I forgot to fix this. There is more. This is only half of it. So some of you found a second solution. What was it? What's that? Was that the other section only? None of you guys got it? Nobody got it in here?
Oh.
All the people who got it were,
9.
yeah, 9 is the other answer. Yeah. Oh, 9, I got 9 here. What's the other than 9? Yeah. -7, that's right. So the reason, the reason that's kind of funny is anytime you have like a 2, that can hide things. Now, I did not take points off you guys if you didn't get both solutions. I just gave bonus points to the people who found both. All right. But this is a kind of fussy issue with whenever you have a square there, you might be missing a solution if you just do what I did. Basically, when I take a 3/2 power, I have to use the plus or minus properties, what it boils down to. When I did 3/2 power, I should put plus or minus this, which would have given me plus or minus 8. So then you get -1 plus or minus 8, which either gives you 9 or it gives you -7. So basically, my error, if you want to call it an error, I mean it's an error, is I should have put a plus or minus here because it's a 1/2 power. This was meant to be a challenge problem. There's nothing quite exactly like this in the homework, but it is like the pi problem. All right. But if you solve the pi problem in the same way that I solved this problem, we only found one answer, right? So in retrospect, there might be 2 answers to that problem as well. Problem 5. Here, we simplify. We get 3/5, x to the 1, y to the 2. So c was 3/5, a was 1, b was 2. Some of you got this. Some of you did not. Problem 6. So here, I can factor x squared plus 6x plus 5. It occurs to me I never moved the camera. Oh, it's been a bad day. I forgot to put my mic on in the first class. That was great. Oh yeah, we've been out of the frame. Well, anyway, the rest of you can look at it in Canvas, whatever you missed. My apologies. I was focused on the, like down here. Anyway, okay, so we factor. And when you factor, you notice that you've got a common x plus 1 above and below. That means that -1 is going to be a hole in the graph. There's my reduced function, x plus 5 over x minus 1. To find where the hole is, we plug in -1 into the reduced function. We get 4 over -2, which of course is -2. So my hole is at -1, -2. Vertical asymptote is coming from that x minus 1, that x equal to 1. The x-intercept is at -5. You could say at -5, 0 if you like. Horizontal asymptote, well, the ratio of the leading coefficients is 1, so the horizontal asymptote's at 1. So there was that. A lot of people got this problem. There was a lot of success here. More people got this wrong than should have. It always happens. It's like a law of this problem. People will do worse on it than I think they will. So f of -1 plus g of -1. Well, f of -1 is 0. G of -1 is -1 plus 2, which is 1. 0 plus 1 is 1. F of g of 0. Well, what's g of 0? Well, g of 0 is 2. What is f of 2? F of 2 is 2. G of f of 0, well, what's f of 0? F of 0 is 1, so that's g of 1. What's g of 1? Well, g of 1 is 1 plus 2, which is 3. I did not. It just worked out accidentally to 1, 2, 3. That was not on purpose, actually. Problem 5 was, so 0 is less than 2. That puts me in this case. So this is absolute value. Absolute value of 2 times 0 minus 3 is the absolute value of minus 3, which, by the way, is 3, guys. Some of you left it as like absolute value of minus 3, but you can simplify that. It's 3. I didn't take a point off if you didn't, but I hope you knew that you could make it 3. F of 2, well, that's right on the dividing line, but in this case, it goes for that formula. So we do 2 cubed minus 1, which is 8 minus 1, which is 7. So there's that one. Now, this here, I probably need to zoom out a bit so you can see it all at once. Let's see here. Let's walk through it. So we factor the denominator to x plus 4 times x minus 4. That tells me there's vertical asymptotes at plus or minus 4. There's no hole in the graph because there's no common factor which reduces. So there's no holes in this one. There is vertical asymptotes, though. The horizontal asymptote is going to be given by 2 because they're quadratic upstairs, quadratic downstairs. So the ratio of the leading coefficients is 2 over 1 because this multiplies out to give me x squared minus 16. Well, there it is. So horizontal asymptote at 2, which I've done here, dot, 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 dot. And my vertical asymptote's here. I draw my sign chart. It bounces off the origin because of that x squared, right? And it has to look something kind of like that. And various people had various parts of this correct, and various people had various parts of this very incorrect. And is diversity our strength? Yes. Then we have great strength on this test because there's a great diversity of wrong answers for this problem. So that means that the class is very strong, right? It means that some of us have things to learn. I mean, I have things to learn, for sure. X minus 3, I need that to be positive because I can't have division by 0. And so that gives me 3 to infinity. Problem 8. There are signs of life here. There's signs of life, but a lot of people got it wrong. I'm not sure where you went wrong exactly. I think usually something wrong happens in this part of the calculation, generically speaking. I did have some people get exactly what I got. Yay. Probably if you got it wrong, you accidentally did something silly like subtract an x from an x squared or something like that. Like you took a difference of unlike powers. You have to watch out for that. Like we can only subtract this apples from apples, oranges from oranges, right? Squares from squares, linear terms from linear terms, and so forth. But anyway, that's how it works out. And so this is the quote-unquote p of x. The remainder is this guy down here, which gives me this altogether. But many people earned much partial credit here, so that was good, because I could see that you'd studied and you're trying your best to do it, and there's just a lot of arithmetic steps to make a mistake in, so I'm sympathetic. This one here, the smart way to do it is to notice that you've got an x squared plus 4 from 2i, and you've got a x plus 3 from the f of minus 3 to be 0 by the factor theorem and the complex factor theorem. So that, when you multiply them, gives you a cubic factor that's you're looking for. And you can divide the cubic into the quartic and immediately get x minus 2, which means you factored it. So now, if you didn't have this thought to multiply the two factors, you could have divided by the one and then found the other through like factoring. Like if you divided by the quadratic, that would have gotten you quadratic times quadratic, which you then could have factored. There's a lot of like other ways to do this besides doing what I did, which was to multiply the factors. But this is by far the easiest way to solve it, unless you just know the answer. Just knowing the answer is always the easiest way, right? But I do take off credit if you don't show work, so there's that.
Oh, I'm supposed to show my work.
Well, you gave me your work, Michael. You're fine. I didn't take points off yours for not showing work because your work's all there. But anyway, so here we have x plus 6 squared because of the bounce there, x minus 4 squared because of the bounce there, x plus 2 because it crosses at minus 2. And then we need a coefficient out front to match the y-intercept. And when you plug in 0, you get this, which simplifies to 1/18. I mean, if you don't simplify the numbers, it's some like hideous 32 over 1,156 or something. I forget.
It was 64. At least I got 64 over 1,152.
64 over 1,000 what?
And 64 over 1,152.
152. And so that means I had to have my calculator to go check your answer, and I did, and I got 1/18th, and I was like, okay, good. but you're right. So this one here, I solve for the square root, square it, and then we get either 2 or 9, but 9 is extraneous. When you plug it back in, it doesn't work. So there's that one. Then problem 12. We first of all move it all. So this is the hardest problem on the test probably, and we move everything to the left-hand side. I make a common denominator. I clean things up. I get to x squared minus 4x minus 2 upstairs, and x plus 4 times x minus 1 downstairs. Now the numerator is not terribly nice, but it does, with the help of completing the square factor like this, which shows that I've got 1, 2, 3, 4 critical numbers, make the sign chart, there's the answer. So difficult, but not impossible, that problem was. So the only other kind of problem I still need to show you guys about inverses, just proper, is if I give you two functions like f of x and g of x, how can you tell if they're inverses? All right, so like if we take the one formula and we compose it with the other, we should get back x after the composition, all right? So we'll talk about that next class is what we'll do. So have a good weekend, you guys.
Thanks for your...
You're welcome, Michael. Sorry I was late.